welcome this morning. I'm Jose Espina, Project Manager for the Energy Pathfinder project. Today we'll be having one of the webinars that we've set up as part of the Energy Pathfinder project. But this one will be looking specifically at retrofitting, monitoring and measuring systems. And we'll be looking at Cork City Council's experience. The seminar will be recorded, as you're probably aware. Just to say a few words about the Energy Pathfinder project. It's a partnership exchange project funded by the Interreg Northern Periphery and Arctic program. It includes 6 partners from 5 Northern Periphery and Arctic regions. The project is focused on historic buildings, and in particular on working out roadmaps to bring these historic buildings to near zero energy. Historic buildings are a very valuable asset for many communities, but they tend to lag behind in terms of sustainability, in terms of energy efficiency, because of the difficulties involved in dealing with often traditional natural materials and the sensitivity of the architectural and construction structure of these buildings. The Pathfinder project is looking at examples, demonstrators of historic buildings in all these regions, and we have 6 buildings were initially selected, and these buildings will be used as test cases for developing this roadmap to near zero energy, which is looking at issues like the fabric of the building, the materials used in the building, the energy, the heating systems, and looking at ways in which these can be brought up to date in terms of standards and regulations without impacting on the character, the historic character, and indeed enhancing the value that these buildings might have for the local community. The lessons of these developments will be fed into an online tool which we're developing to allow other owners and stakeholders in historic buildings to take a similar journey to near zero energy by seeing what actions and activities would help improve the energy efficiency, maximize the sustainability of the energy, and introduce fossil free renewable energies into the buildings instead of the traditional sources of energy and heating that these buildings might have. One of the aspects of the project, however, is to look at the potential of energy monitoring and management and improved energy management of buildings in order to create even further economies in terms of energy and greater sustainability, and also to monitor the effectiveness of renewable energy systems that might be installed. And this is what this particular webinar is focusing on. And we're looking at the experience of Cork City Council that our partners work closely with, and see Energy Hub in particular. And they'll be giving us an idea of their experience in this area through another European project, which is quite extensive. To introduce our speaker, I'd like to ask Katrina Courtney, manager of NC Energy Hub, who is leading on the communications work package for the project, and also works closely with Brian Cassidy and Cork City Council in the renovation and retrofitting of properties in Cork City. Katrina, just before that, I'd like to say, if you have any questions, please enter these questions on the chat box, and we will take them all when the speaker finishes. And basically, enjoy the webinar. Katrina?
Thank you, Jose. And so we are delighted to have Brian Cassidy, Senior Executive Engineer at Cork City Council, join us here today for this webinar. Brian commenced his working career as a marine engineer with the Naval Services. He then joined Cork City Council with responsibility for the council's transport, vehicles, and the electrical and mechanical engineering aspects of the council's public buildings and water storage network and pumping stations. Brian joined Cork City Council's Social Housing Maintenance Department in 2008, and Brian is responsible for the retrofitting of Cork City Council's social housing stock and for bringing the vacated social housing stock back into productive use. Brian has collaborated with both public and private bodies to improve the energy efficiency of Cork City Council homes through shallow, medium, and deep energy efficiency retrofitting projects. Brian leads Cork City Council's team on a number of European-funded projects that seek to increase awareness of the need for retrofitting, demonstrate innovative approaches to reducing carbon consumption, and examine ways in which retrofitting can be done more productively. Brian is also a member of Engineering Ireland Executive Board and chair of the institution's Audit and Risk Committee. Brian represents Engineering Ireland on the Construction Services Group Consultation Committee on research into disruptive innovation for sustainability and climate action. Brian is also a member of Cork City Council's Climate Action Team, Energy Team, and Smart Gateways Team. So, as mentioned, Brian Cassidy has led a large number of Cork City Council's social housing retrofit, and the focus of this webinar will be on 3 projects that Brian is involved in that will utilise monitoring and measuring systems. So I'd like to hand you over to Brian now. Thank you.
Brian, can you unmute yourself?
I'll have to be heard now, Jose. Yeah, so thank you everybody, and thank you in particular to the Pathfinder project for giving me the opportunity to demonstrate Cork City Council's work in the area of monitoring and measuring what is happening when you retrofit a home or carry out energy efficiency improvements. As Katrina said, we have done a great deal of work over the years with NCE in particular to improve the standard of our accommodation. For us, it's a twofold benefit. It's both reducing carbon consumption, and it gives us an improvement to improve the quality of the homes and at the same time extend the life of many of the homes for which we maintain and have a responsibility. So I'll just share my screen there now, if I can. All right, have you got that?
Yes.
Yeah, okay, great stuff. So yeah, so as Katrina said, I'm responsible for the energy retrofit program in Cork City Council and associated projects, which would be mainly project funded through EU programs and the Department of Housing here in Ireland, their programs. So a little bit first about Cork City Council. I'm sure you probably have heard all this before, but anyway, it's a city with 210,000 citizens, an area of 187 square kilometres, in which there are 10,500 social houses owned and maintained by the City Council. It is the democratic institution closest to the city, and it is made up of 5 electoral wards in which the people in those wards elect people onto the City Council itself for decision-making purposes. The activities and responsibilities of the council within the administrative area include social housing provision, the planning and economic development of the city, the provision and maintenance of the city's infrastructure, operations, maintaining the roads and the environment in the city, promoting communities in the city, promoting culture and placemaking, making the city a better place to live, work and invest in. And also we have a section on corporate affairs and international relations, which is a very outward looking department seeking to make connections between Cork and the wider international world. So why retrofitting? Well, the main reasons for retrofitting are to reduce and remove carbon emissions from our society and from our activities. Also to improve, as I said earlier, the quality of our older homes. reduce the incidence of fuel poverty amongst our tenants, which, given that they would be mostly lower income, is probably higher than the norm. It's to support the government's climate action plan, support our own City Council's sustainable energy and climate action plan, and it's part of the drive towards zero carbon in our society by 2050. And where retrofitting is concerned, the country has two sets of targets. One is to have 25% of the stock completed and brought up to a near zero energy building standard of a B2 energy rating by 2030, and 100% of the housing stock completed by 2050, which is quite a task and quite an ambitious target to set. Also, if we reduce our carbon emissions, we reduce the possibility of flooding in our city. Cork's a very low-lying city, and you can see from one of the maps there, the red area there just shows how prone large areas of the city are to flooding if there was a 1 meter rise in sea level. So where I work, this housing maintenance department, we have 10,500 social houses, and it's growing fast. Age range is commenced in 1886 with a place called Madden's Buildings with workmen's cottages, right up to the present. Over 50% of our housing stock is pre-1970, so it's ripe and ready for the retrofitting process, which is good news for us. We have an annual maintenance budget of 12 million, which would include exclude the capital program and the home improvements program. Our maintenance program is currently mainly response-based, but slowly but surely we are evolving planned maintenance programs, and they are becoming more dominant. Over the years, we have seen an increased duty of care due to improvements in the Ireland's Rental Standards Act, the setting up of the Residential Tenancies Board, and the development of building regulations. And that has had quite a significant impact on us over the years, because if you think about it, when we started in 1886, the tenants were responsible for the house, but all there was walls and floors and doors. There was no electrics and no plumbing, which and no toilets, nothing inside the house. Everything was external to it. So the level of maintenance was very low, but that has changed over the years due to advances in technology, people's needs for improved standards of living and improved quality housing. And also a home is where people spend more and more of their time. And we have had an increased workload due to the increased demand for social housing, the growth in our social housing stock, the improved building standards I mentioned earlier, and regulations, and also the high cost of housing is pushing more and more people into the social housing bracket. Our history in retrofitting won't be new now to the people in NCE, this piece, but we started in 2010 when we set about doing a demonstration project for the Department of Housing to see if in the Irish situation we could actually do retrofitting with people in situ. So retrofitting was, especially deep retrofitting, was never going to take off if people had to be decanted or removed from their houses and housed somewhere else. So we needed to show that we could do this in-house, and this we did in 2010 in a place called Sunview. There were 32 apartments arranged in 8 blocks of 4 each, 2 up, 2 down. And that contract was won by Northside Community Enterprises Installation. And that was our first step into the foray, and that project worked out very well. And our tenants are they were the first to get the benefits of improved windows, improved insulation. And back then in 2010, the gas central heating system was considered very CO2 friendly, not like now where the emphasis has changed to heat pumps, which are now our standard fit. We also did a shallow retrofit scheme supported by the Department of Housing here in Ireland, and we put attic and our cavity wall insulation into 6,500 of our social housing stock. That was between 2013 and 2018. And then we participated in a number of better energy community schemes with a local community-based organisation, NCE, and areas like Cork, Charles Daly Road, Edward Walsh Road, Wolftown Street, Sierraville Place. I'd say it's about, and Ardvallia, Glenamile Lawn. I'd say approximately 500 units using the BEC scheme program, which in itself has evolved over the years, because in the early days, a lot of it was piloting and seeing how good can you do and how well can you get it. Whereas today the BEC scheme is under different names, is focused on, again, achieving the B2 standard. We've done BEC schemes on houses in Ballyfahan and Churchfield. And in 2017, since 2017, we've done 210 apartments units in Wolftown Street, Allen Square, Old Market Place. And they have all been brought up to a minimum B2, but many of them are achieving A3, and I think there's one or two in at A2 as well. And you can see that's an example of one here, the blue units here, and in the left-hand side, left center of the screen. So our retrofitting targets by 2030, we are targeting this is a national target now, not Cork City Council, 500,000 units to be retrofitted to the minimum B2 standard. And if we apply that to our stock, that means we must do 2,625 units by 2030, which is an average of 263 homes per year. An expenditure of somewhere between 10 and 15 million per annum is required. And to achieve the rest of the target between 2030 and 2050, the remaining 1.5 million homes in the country to be retrofitted to the B2 standard, if applied to Cork, we'll see that 7,800 homes must be done during those 20 years, which is 394 homes per year, and an expenditure in today's terms of between 15 and 22.5 million per annum during those years. So this is a very ambitious program. It's labor intensive, and we certainly hope to be there in terms of those agencies that achieve those targets. So reporting, measuring, monitoring, and reporting systems. So if you're going to spend that amount of money, it would make sense to see, well, how are we doing? Does it bring the benefits we all claim to do? And does it do it specifically where we live and where we provide our houses here in Cork City? So in 2018, we approached the department, our own housing department here in Ireland, and said, we're spending all this money. We'd like to do a monitoring and measuring campaign to see, do we get the results of before and after? So with that in mind, we got funding to install monitoring and measuring systems in 8 housing units in an apartment block, in a set of apartment blocks in Cork, which we hope to retrofit next year. And it's been expensive. It works out at close to 16,000 per unit. It's not cheap. And that's purely for monitoring, measuring, and reporting. We're also involved in a project called Red Wolf, in which Hoses Housing Association, Carboning Housing Association are also partners. And this project is very interesting. What it aims to demonstrate is that if you have a home which is heated using electric storage heaters and has electricity provided by solar power and by a battery storage unit, you can then target electricity from the grid when the carbon content is low. So it is known 2 or 3 days in advance when the carbon content of the grid is low. So the algorithm will say, okay, we won't take electricity off the grid at the moment. We'll use what's in the storage heaters, we'll use what's in the battery, and we know based on predictions of previous history that they will have enough electricity to do that. And tomorrow night or tomorrow, say if the sun is shining brightly, or if we know the wind is high and the wind turbines are in operation, we'll charge up those storage heaters and those the battery for the rest of the house on that occasion. So that project is in its early stages. Because of the intrusions into the household, it has been delayed a number of times with COVID, which we're hoping now with the vaccine rollout, we will get back on track and see the algorithms, see the equipment installed and see the algorithms developed. And Cork City Council is supplying 10 properties for that project. We actually had difficulty identifying 10 houses with electric storage heaters in situ, because primarily when our houses were built, they would have had an open fire, And subsequently, between 2004 and 2008, we did a massive gas installation program. And that just left people who didn't want gas and didn't want central heat and didn't want a second bill to a gas company in addition to a bill to an electricity company. So we had about 300 houses to look at, and eventually we found 10 that had electric storage heaters. So we're delighted with that and delighted to participate in the project. Another project we're involved in is a project called Mini Store, which is very similar in many ways to Red Wolf. But what it looks at is looking at solar thermal and using solar thermal to store heat in thermal change materials and in phase change materials, and being able to draw down that heat then when you need it in the house. And it would act like a battery in parallel with your existing gas boiler. And in addition, it is looking at the main supply and seeing, well, when can we get low cost stroke low carbon electricity from the mains to supplement the electricity being consumed in the house. So there are 3 projects that we are involved in. So why bother? Back to why bother? Well, as I alluded earlier, we needed to answer questions. So in my background, machinery failure was a big thing. So we needed to record a lot of details about machines in order to predict when they were going to fail. And, you know, especially if you're planning maintenance periods, you need to know that it's going to last 6 months. If you're going to bring a ship in for 6 months, the machinery needs to last 6 months without needing maintenance. To show results, so you might want to know what your temperature is. In our case, with retrofitting, you might want to know that actually, yes, the temperature does improve in the house. Very important to justify our budget. Does the money we get for a project match the expenditure that we do in a project? And we all hope that in all cases it does. To identify opportunities for improvements, if you just take the building energy ratings alone, if we are able to measure what the energy rating is in a house, we can then determine what improvements we can make to improve the energy rating in the house. If we've a pump operating and we know what its efficiency curve is like, or this one here is very similar to what you'd see in a car. For a car, so you want to operate at peak efficiency, but then you need to be able to measure the car's performance. And finally, to manage results, if your budget is going over expenditure, you need to be able to reduce expenditure and bring your budget back on track. So measuring is very important and a very useful exercise to do. So how do we measure? Well, traditionally, the human being, we ourselves are very good at monitoring and measuring for our own individual cases. We have sight, in which we can see things in the distance and make guesstimates as to how far things are away. We have hearing, in which we can hear what's around us and determine, are they near or are they far, and what is the noise, the likely source of the noise. We have smell, which can tell us if there's danger or if there's something nice around the corner. We have touch. We can determine whether something is friendly towards us or whether it's hard or whether it's soft, and that's of great benefit to us. And then there is taste. We use our taste to determine whether food is nice or food is not nice or good for us. So those senses are all very good. But in terms of communicating with each other, whilst we can verbally communicate, over time that is lost. And what's missing then is scale. We can't do it on 1,000 different things. Units of measure, when we're communicating together, we don't really have good units of measure that stand the test of time. Integrity, what I think is a nice taste, you might think is awful. What I think is loud, you might think is not loud. And memory, can we remember, our memory is prone to change, and we don't always remember what something was from the first time that we came across it. So there are limitations to what we have with our senses. So what to measure then in terms of retrofitting? And we're going to use sensors. Well, temperature internally and externally would be important. Air pressure is important. CO2 levels, particularly as we seal up our homes and reduce the airflow through them, CO2 becomes more levels, and CO levels become more important within the home. And some people have extended that out to PM10s and other what would you call it, other particles that are emitted from clothing, from furniture and other items in the home that I think are important and should be measured. Energy consumption is always important, particularly for those where countries import energy like ourselves. It's a big cost, so energy consumption in the home is important. In our case, gas consumption, an awful lot of our vast majority of our homes have gas heating, so gas consumption is important. And coming more and more to the fore, heat pump usage. Does the heat pump operate effectively and efficiently? And then externally, in order to get a gain of what those benefits are, you need to know what's going on outside the home, and install a weather station, which again records many of similar characteristics, but also wind speed, wind direction, rainfall, solar radiation. If you're using PVT panels, it'd be nice to know what the solar radiation actually is in your neighborhood, particularly if you run into a problem. The UV index for a similar reason, and the chill factor. How cold is it really outside when you take the wind direction, wind speed into account? So systems of measurement and recording. So we've the basic systems whereby we insert sensors and record information at set time intervals, like you would with your ESB bill. If you know the bill is coming up every 2 months, you'd submit a reading every 2 months to see what to give them the reading. You can use data loggers, which means you don't have to go as often to the site, but you do need to go and download the information from the site. And then there's digital remote monitoring, sensing and recording, which is the one we have opted for with Ministore, with the EEMMR and with Red Wolf. So the great thing about digital remote monitoring, sensing and recording is it opens up an avenue towards digitalization, whereby you can make decisions based on the data that you receive. So data loggers, I have a photograph there of 2 data loggers that I bought. We bought in a bit of a panic because we were having delays installing equipment on the Ministore project. So I said, let's get 2 data loggers. So these 2 data loggers measure temperature and humidity. They're made by the same manufacturer, they're the same type. One doesn't have a calibration certificate, this one here on the left, and this one does have a calibration certificate. And the order of cost is quite different. So this one on the left with no calibration certificate costs us €60. This one here, if we had gone for the company manufacturer's calibration, would have cost us about 200. But if we went at external calibration to say the UCAS standard, it would have cost us €320. So it gets quite costly once you get worried about calibration. My own view is that external certified calibration isn't that necessary for what we do. We're not working in the nuclear field or anything like that, and that the units that are, I mean, they're all calibrated, they're just not certified. You know, someone hasn't sat down and said, oh yeah, it does exactly as it says in the tin. So I'd be quite happy to use the cheaper ones for most purposes. And in fact, I did a quick test there, and on temperature, the maximum deviation was 2 degrees, which, you know, given that they weren't exactly recording it, they were about 2 minutes apart in their recordings. Isn't that great? And the humidity difference was 0.5%. So with these units, the frequency with which you record the data determines the length of time that this data can be stored between downloads. So the maximum, like if you extend your data recording intervals out to 15 minutes, you can record data on these for 5.5 months. So that's quite, and I think the other one is about 2 weeks or something like that. If you went down to 5 minutes, there's quite a differential there. So remote monitoring and sensing. Here's a diagram from the Ministore project, very similar to the Red Wolf system. So basically on the periphery here, we have our monitoring equipment. We have a weather station in the house. We have electrical energy meters. We have heat meters. We have temperature and humidity sensors in each room. We have a gas flow meter. we have a pulse to, and then we have, they're all linked with the dotted lines, it's wireless, and with the hard lines, it's by wire into a metering gateway, which communicates with an Ethernet, and you can read all the data then on a screen attached to the Raspberry Pi. And once you have that information coming in and acknowledged correctly, you can export it then anywhere. In our case, it's going to our partners in the Greek University in Thessaloniki, and they're taking all that information. With Red Wolf, it'll go to IT Sligo. They're taking the information, they will take the information there once that system is installed. Quite an involved unit, a lot of IT expertise needed. There's really 3 skill sets needed for this. One is the electrical installer to install the wiring network. And then you need the, sort of 2 for this one, actually, sorry, I said 3. Red Wolf has 3 because of the electrical storage heaters. And the second thing you need then is you need a SCADA person, stroke IT person, both to program the system at the Raspberry Pi level and over here in Greece to develop the SCADA system. So what I want to do now is go and show you how to set up a data logger, and bear with me while I get this going. Right. All right, can you see that? Yeah, okay. So a data logger, to set it up, you set up what you basically that's what it is. It's your name, you can name it. I've named that 1799536, and NCC is really no certification. You can set your temperature scale at degrees centigrade or degrees Fahrenheit, and you can select how often you want it to log a reading. And you can see there, if you do it every 15 minutes, you get 5.5 months. But if you do it, I go up a bit there now. If you do it every 10 seconds, you only get 45 hours. So depending on how often you want to visit the site and collect the data, and how important the differential between those time intervals is, you can see there's a huge differential between the time you can collect the actual data loggers and download the information. You can set alarms on it, a high alarm and a low alarm, and that shows up on your readings. And you can set the temperature for that then, and you can set the high level and the low level temperature. Also for humidity, a high humidity level or a low humidity level, and also you can set what those levels are here and here. And then when do you want it to start? Do you want it to start immediately, or do you need to take it out of your fields, out of your PC, drive to the house and install it? So you want it to start sometime later. And then it's ready to go. Next thing you can do is you can, when you've collected the data, you can stop the UCC, the USB data logger, and download the data, and it'll be saved to your PC. So in the interval between this was last stopped and now, it has recorded 2 readings. So that's great. And we can save that information. Okay, and then you can look at previously saved data. So we'll just take this data set here. So you can see over time, you can see the dates appearing here, second up from the bottom of the screen. And the other thing you can do, which is very useful and probably the best part of it, is you can export it to Excel. We'll have to change. You can't see the Excel. Can you see the Excel spreadsheet? Yeah. And then you get the data. I don't know what's happening that now, but yeah. And you can get to see the data then here. There's the data, the date, the time, the humidity, the dew point, and the serial number of the machine. So that's a data logger in operation there. Next, no, where am I relative to your good selves now? Your screen sharing. Yeah, so back to the presentation. Well, back on the black screen, are we? Yeah, okay. So the next thing I want to show you is a video that the Mini-Store project produced for its monitoring and measuring system. If you keep an eye on the bottom of the screen, it'll show you what the various charts are for. So this platform is to allow users, i.e. tenants and building managers, to access the system. So it's a login account that you will have if you have access to the Mini-Store project. And here you get a graphic of the house in microgrid's tab, and you can get information about the house, the status of the system, and the environmental conditions. So you can see you have electricity storage, you have what's on the grid, thermal storage, and what you're getting from your natural gas system. You also get information about the weather and the energy flow in the system, and what demand response events have taken place. You can see in the bottom left, household conditions, or even the energy balances, whether you're importing or exporting energy overall. Then there's a data analytics tab. You can get a real-time overview of total energy and power flow. And this one unit also goes into price and into the production and consumption of thermal and electrical energy and their correlated costs. You also get thermal and hot water energy flow, and that's from the gas, from the heat meters. You can see historical information by selecting a desired date range. And you have a control panel then, which is dedicated to the control actions that can be performed by the user, like setting temperature internally. You can create schedules to heat or cool the house at predefined and preferred hours. And they're, as well as being available remotely, they're available manually as well, these facilities. And you can do it for the whole house or independently for each room. So the user is also able to go to auto mode and allow the system to adjust automatically based on the temperature controls you set, and that's based on historical data. There's a prediction tab that provides insights about the forecasted load consumption and production, which can be used for scheduling the system's use. And you can view all available forecasts for the day ahead. The user can compare them to the actual real-time data or even the historical data from past days. The user can view plots of the possible deviations of the predicted values from the actual measurements. And the demand response tab presents the demand response events that have already occurred, events that are currently active, and events that will occur in the future. You can get access to informative notifications for system errors and other events, i.e. when your battery or your thermal unit is low in energy. You can change the language of the platform, which is very important when you're dealing across many nations. You can get access to user preferences and settings, as well as disconnect from the platform. Thank you for watching that video. Now, the next one then is our energy efficiency monitoring, measuring, and reporting system, which we have done really for the benefit initially of Cork City Council, but really to see, are we doing the right thing in our apartments and our houses? This unit, can you see that screen? It's got Cork City Council on the left. Yeah. So this system, we developed locally here in Cork with a local company called Ace Controls. And it's based on 8 houses, and you can see details on the 8 houses there, and there's also a weather station located here. You can get more details on each house here on the left-hand side. Get you a new share there. I might be able to. Can you see that share? No, it's not. No, sorry. Get this going now. Slideshow. Okay, this isn't coming up for me now. No.
There.
Right, this isn't doing what it's told for a moment. Just give me a tick there now. Let's see what's going on here. There might be too many things opened up. Not knowing what, Aha, it closed off me because I didn't use it. Okay, do you see a kind of a graph there?
Yes.
Yeah, okay. Right. We're onto something here. We're onto something here. Doesn't want to let me in. Okay, so why won't it show me? Let me get out of that. Okay, let me get it established first, myself. And then we'll take it from there. Okay, I'm going to go into this again because whatever it's doing, it's not letting me give it one more go. Can you see a screen called TeamViewer? Yeah, okay. Good, I'm in there now. Hey, you see that? Shandon,
Yes.
Picture of Cork City, very good. Okay, so this is our what we call our energy efficiency monitoring, measuring and reporting system. It's been installed over the last year in 8 of our social housing units. It's been fairly tortuous getting it completed now due to access issues, and the way we view things on the screen has been an issue in interpretation of what we think is true. So there's 8 houses and we see them numbered there, and we can see details of energy consumption in the houses here. And we have the weather station unit here. And for those that may be interested, it rained heavily, very heavily, quite here yesterday. You see there's no rain today. So there's 2 spikes, you see it there between 3 and 6 o'clock, and there's a second spike there. So that's giving you the rain rate instantaneously on any given time in it. So it can give it to you like within a specified time range. For today, that's since midnight. In the last 24 hours, that's up to about 10 o'clock or 11 o'clock yesterday. Yesterday, from midnight to midnight. The week to date, which would be from midnight as well. Last week, which is last Monday to Sunday. And you see there, we only got rain on those two occasions on Saturdays. Well, Saturday and Sunday. And the month to date, you can see it there. So it gives you loads of options. The other thing it allows you to do is to download the data. Don't know where that is now. So you can download the data in various formats. Yes, one of those guys anyway. I think that he's not coming out for me today. And you can save it to CSV and then export it to Excel. If you take a particular house, let's just say number 6 there. So we get a lot more detail on each house in there, and we get the living room temperatures 19.7 degrees. Temperature in the bedroom, you can see it went down there from midnight to overnight. You can collect that over time, and what we hope to do is to get someone to analyze it when the retrofitting is complete and see how real a benefit did the tenants get, knowing what their gas consumption was, knowing what their energy consumption is now with a heat pump installed, and see, are they getting the benefit of the temperature? If they weren't achieving nice normal temperatures or indoor temperatures between 18 and 21 degrees before, are they getting it now with the money they spend? So that's basically our monitoring and measuring and reporting system. So I'll go back to the main screen. So a final note, our own census, yeah, limited, very low cost, very good for us personally, but with very limited transferability and long-term storage. If you just use sensors with manual recording, again, it's low cost. You have to manually record and you have to manually collect the data, manually store it. And again, transferability is limited by your ability to transfer on paper. You can use data loggers, again, they're low cost, auto recording, and that it records at time intervals you set, but you must manually collect it but at longer intervals. Good transferability, because once it gets onto an IT system, you can send it anywhere. And then you've remote monitoring and measuring, very expensive, has long-term memory, automatic data collection. You have the ability to make changes based on information provided, excellent transferability, and demand response stroke digitalization possibilities. So that's it. I hope that's has been shared, gives you some insights into our experiences with monitoring and measuring systems. And I'll hand you back to Katrina, if you have any for questions and answers.
Thank you very much, Brian, for your presentation. Extremely comprehensive, complete, and throws up a number of very interesting issues. We've got a number of questions on the chat there. Because of the limited time that we have, we've only got, well, we're supposedly only 7 minutes. I think we're going to have to extend it a bit longer. But I'd like to take the practical questions first before moving on to the more theoretical ones. So we have one from Dietmar Holzer and he's asking, did you measure CO and CO2 to check internal quality? If so, shouldn't one also measure other parameters like humidity, PMs, volatile organic compounds, in order to be able to evaluate why tenants maybe don't open windows? Brian,
yeah.
Do you have a...
Yeah, we have in the living room of the apartments on our own energy and environmental monitoring, measuring and reporting system. We are measuring temperature, humidity, pressure, CO2, carbon monoxide, and also the lighting levels. Now, on the other projects, there's no limit to what you can measure. I mean, there's sensors out there for everything. And with electronics, you have the ability to capture the measurements and put them on a system. But there's two things you must consider. One is costs, and two is what are you trying to achieve? For us, we're trying to achieve the benefits of, what are the benefits of the retrofitting process from an energy point of view and from a well-being point of view. And now I know when you get into well-being, you can go into PM10s, you can go into volatile organic compounds, but we don't really see them at the moment as being relevant to our aim. You know, they're really more detailed further down the road issue. Radon is another one. We could and should measure in the home, but we're not. We can add it in later if need be. So really you have to decide what is it you want to do. Now that we have these systems up and running, adding it to them in these locations shouldn't be that great a cost if we want to measure, you know.
That's very useful, Brian. Thank you. I've got a number of questions. Caroline Akiboye. One is, what is the volume of phase change? What volume of phase change material is in the Ministore, and how many days of useful thermal energy is stored?
Now, that's a very good question, and I'll be honest with you, I don't have the answer, but I can research it and come back. We haven't actually got the Ministore device itself hasn't been installed yet. It's due for installation in September. And the important thing for us was to get the monitoring and measuring campaign going for, initially we hoped a year, but in our case it'll be 9 months, 8 months before the Ministore device is installed. Preparations for that installation are going on at the moment. The volumes are very low enough. The overall volume is 0.0 of the system in terms of the box is 0.72 meters squared.
Right.
So everything falls from that.
Great. And another one from Caroline. Do you find that condensation is an issue in the housing stock? And is MVHR or demand controlled exhaust ventilation regarded as a priority?
Again, no, we're back to costs, and we're back to the fact that we have existing buildings. Mechanical heat and ventilation recovery is a great idea. The downside is it depends on electricity supplying air into the house. So that I'm personally not a big fan of that idea, but I can see the merits. In terms of condensation is an issue in houses where the moisture barrier has broken down on the wall, and so moisture is able to seep through the wall and get inside the house. We would have a number of properties suffering from that. They're the older houses. You could say poor plaster work, but after 50, 60 years, you know, you've got your life out of the plaster anyway, and it's time to replaster. And this is where retrofitting is a gift for us, because it allows us not only to seal up from condensation again, but also to seal up from a heat transfer point of view in the house. You also have moisture build up because of lack of ventilation. It's a big issue, particularly in fuel poor homes, and not just fuel homes, but we seem to have lost the idea that we should open our windows for half an hour each day in the morning, preferably after being in it all night. And we need to get back into that mindset that we need to open our windows, winter or summer, for at least half an hour each day. Now, the mechanical heat and ventilation recovery people won't like to hear that, because they believe that their systems will withdraw the moisture from the home. But in the absence of MHVR, that's what we should be doing.
That's great, Brian. Now, I've got a couple of questions, one from Katrina herself and another one from Christoph Bartholomeus, and they're both around the issue of tenant engagement. Are there ways in which tenants can participate in the feedback or the management of these? Christoph asks, is the monitored house solution connectable to smartphone, internet box, smart meter, which could facilitate mass analysis of to be retrofitted as retrofitted homes? So it's a whole issue of how do the occupants, how do the residents relate to the various systems?
Okay, on the EEMMR, each resident has a tablet and they can see what we can see. There is no control system at the moment. They don't have the ability to set anything. It wasn't designed with that in mind. It was purely monitoring, measuring, and reporting. It doesn't have a facility for upgrading. That wasn't part of the installation project. It is on mini store. It will be, because they will have to set the temperature of the rooms, and they will have to, they'll be able to look at and adjust the temperature controls. They'll be able to adjust when they're using the thermal units, the mini store device, or when they're getting, you want to use the gas. They'll be able to make a lot more decisions. But the whole idea of the project is actually to take decision making away from the tenant and to put it into the algorithm, similar to Red Wolf. Will be similar. Instead of the tenant wondering when he should use the thermal device or when he should draw electricity from the grid, that decision will be made by the algorithm. So the owner-occupier tenant won't have to worry about that.
I see. We're running a bit short of time now. There's a couple of questions really on information and the data collection. And the question is, do you have plans to use the data collected through the EEMMR and presumably other projects, the Minister and possibly Red Wolf as well, to provide guidance on energy behavioral change? And how can this information be accessed by interested stakeholders?
The data is, well, first of all, we're in the early stages still. We haven't actually done the retrofitting, so it's still data collection and teasing through issues. So that's the first thing to point out. We do hope that someone in a year or two's time will, some research institution will be able to avail of it, either openly or through a private arrangement with the council and the tenants. The important thing we must bear in mind here is that whatever analysis is done, the tenants' integrity and anonymity is essential, and we must protect them from, in accordance with the General Data Protection Regulations. You know, they've offered to give us this information, they've offered to have it online, and they have offered for it to be analysed, but they haven't offered for it to be thrown around everywhere with their names on it, if you know what I mean. So I don't think there'll be much analysis done until after the retrofitting is complete, a year after that, to get a full set of data.
Thank you, Brian. Now, there's a couple of other contributions on the chat. I'm afraid we don't really have time to deal with them in any detail, but I'd like to thank everybody for attending. Brian for his very interesting presentation, which really shows up the challenges of any agency that is looking at the whole issue of energy monitoring and having to define the objectives, having to look at your costs and see what you can actually afford, and making sure that the results and the information that you get out of this monitoring is really tailored to the objectives of your project, and it's information that you can actually work with. The other, I think, really interesting issue is that there's obviously a lot of data information being collected on this subject by different projects, by different agencies, which it would be good to actually be able to crystallize into some sort of concrete lessons, concrete best practice that could actually be used by us and by other stakeholders in future in terms of developing projects like this. We will actually come back to anybody that's placed any questions on the chat with any further information. Please also feel free to email us for any information, either from Brian or from anybody else from any of the other projects there, and we will follow that up. We're holding a series of webinars as part of the Energy Pathfinder project, organized by NC Insulation. The next one will be in autumn. We haven't set a date for it yet, possibly in October, and will hopefully be around the theme of code design and user participation in the retrofitting of historic buildings. We'd also like to ask you, to remind you, to sign up to the Energy Pathfinder newsletter, which you'll find on the Energy Pathfinder website, in order to be able to be kept informed of developments in this project, of links with other projects like the ones that Brian has described, and indeed other initiatives that we'll be undertaking, hopefully now that the lockdown restrictions are being lifted. Without further ado, I'd like to, you'll find the website details on the chat, and I'd like to thank you all for attending. Thank you to Brian for his fantastic presentation, and we hope to continue hearing from you and working with you in the coming months. Thanks a lot, everybody.
Take care, guys.
Thanks very much,
Happy
Brian.
there now, Katrina, yeah. Got away with it.
Thanks very much.
Yeah.
Great.
No, I'm going to let you close it. I'm trying to get off here. The problem with too many things are open, Katrina, I don't know whether I'm coming or going with it.